So thank you everybody for attending this talk. Today I'll be talking about a case study of how our product team moved on to TiDB from MySQL. The interesting bit about this is we are actually a product team, we're not an infra team. I think there's many infra teams sort of hanging around in this conference. So we'll talk about sort of where we came from, why we're going there, and all of that. So the goals of this talk are threefold: to share our experience and our learning by explaining why we chose TiDB, sort of how we chose TiDB, the context around it, as well as showing some of the work needed to run TiDB in production. Finally, we'll wrap up by presenting some problems we encountered and how we handle those problems. Are there questions at this point about the goals of this talk? Yes, I'm breaking the normal mold by asking for questions sort of in the middle of the talk, so please feel free to ask as you think of them. Oftentimes people forget their questions by the end. Okay, continuing onward. So quick outline, I'm going to talk a little bit about our team because our team impacts how the decisions were made, as well as introducing our product so you can sort of know what are we actually doing, like what are our customers actually seeing. And then explain why we're looking for a new database and how we decided on a solution. Followed by sort of a quick section on the areas of work, just a subset because we don't have that much time. And then Christina will lead us off with a deep dive of some of the unexpected problems we ran into, and then finally I'll conclude. Okay, so let's start with the team. So our team is actually much larger than this as a product team, but these were the key people who sort of worked on this project of migrating our database. A little bit more about the team is that we all come from infrastructure backgrounds, and this is important in the later decisions, despite the fact that we're working on a product team. So Jacqueline and myself did research on RamCloud and Arachne, which are sort of distributed low latency key value stores. Christina comes from a background working on performance and reliability at Facebook. And then Lei comes from Intel and New Relic, so also low-level systems for observability. So now I'm going to say a little bit about our product, just to give you a picture of what kinds of data we're handling. So Square Messages is a product that unifies buyer-seller communication for Square sellers. What do we mean by unification? So for sellers, they see a single interface in the Square dashboard app, as well as every single Square point of sale, where they have a unified conversation with each buyer. For Square buyers, they see email, they see SMS, and they see Facebook Messenger. We'll eventually integrate more platforms. So these are the three that we're currently on. So you can see on the left here, we have the buyer experience and the seller experience. Finally, we offer a third sort of integration point within Square, which is that Square services can call us through an internal API to send messages through us. And why would they want to do that? Well, the messages they send through us, for example, appointment reminders, receipts, and invoices, are now visible inside the Square Messages UI. And moreover, the replies to those messages are visible to sellers. If they do not integrate with us and they directly send SMS, then those replies are not visible. So with all this in the product, we sort of handle millions of messages per month. So we're certainly not at Google scale, but we have moderate volume. And lastly, I want to point out that because we have all these services sending messages through us, our workload is actually very write-heavy compared to many other workloads out there. So I'm going to go into a little bit about our problem. Like, why are we looking for a new database? Well, we were originally running on AWS RDS MySQL, which is also relevant for a future discussion. But the high-level bit is that our database was simply growing too large for a single machine. So we're getting close to 2 terabytes around the time of migration. We were starting to see increased latency on a larger and larger frequency of queries, and schema migrations were starting to become risky. Moreover, there were migrations that we were just afraid to run because we knew they would bring us down for a long time. For example, column deletions being a very common one. So you have a whole bunch of columns that are sort of marked deprecated in your schema, but are still sitting around your database. We're very happy to be able to get rid of those soon. Any questions at this point about our product or the problem we're trying to solve? I hope you're not all falling asleep.
I have one question. You had one primary database, or was there, you have another database for high availability in another location, or how did you handle that?
So when we were first starting Square Messages, right, the product itself wasn't yet established. So we had a single read-write replica, and then we had a read-only replica effectively for quasi-analytics, but also as a failover. Yeah, but I think it was a different availability zone, but the same region. We've always been in US West 2. Yeah. Other questions or comments at this point? Okay, I'm going to go ahead and move on. Thank you for the thumbs up. Okay, so how were we deciding what to go with? We started out by brainstorming a whole bunch of sort of requirements for what we might like in our new database, and then we threw them all out the window. The primary reason for throwing them out the window is because the single most important criteria for being able to run this solution within Block is that somebody else at Block had already run it. And the reason for this is because we have unique compliance and networking constraints within Block because we're a fintech company and we also operate on PII. So like, if you just pick a random solution off of the internets, let's say Cockroach, and then you said you want to run it at Block, you got to go through legal review, you got to go through security review, you have to go through compliance review. And that was a lot of pain that we as a product team did not want to go through. So instead, we sort of looked at the existing options at Square that somebody had already gotten approved through these processes. So the different options we looked at, manually sharded MySQL is still the blessed path at Block. It is very sad, but this is still the case. And it's blessed path in the sense that it's the path that most teams have chosen to take. It's the path that our sort of online data stores infrastructure team supports. But of course, it increases complexity in your application, it slows down feature development, and you have to deal with all sorts of pain when you do schema migrations tool, despite the existing tooling. So that's manually sharded MySQL. And then we have Dynamo. So Dynamo is very, very popular for teams with very simple data models. If you have 1 or 2 tables, if you're okay with a limited number of global secondary indexes, Dynamo is an excellent solution. In our case, we had sort of very large relational data models for our transcripts and utterances, as well as our metadata and various AI analytics. So Dynamo was sort of not a good choice for us. And then there was Aurora, which was kind of interesting because if we were read heavy, we'd actually be okay, but we actually are a fairly write heavy workload, as I mentioned earlier. So the Aurora's lack of write scalability was actually a pretty big problem for us. Moreover, like, yes, it's a little bit more scalable than MySQL, but we didn't want a solution that would require us to find a new solution a year later. So we wanted to sort of come to a solution that would allow us to last for many years. And then that brings us to the new SQL databases. We have Vitesse and TiDB. So Vitesse was actually used by Cache within Block for a while, and it was considered operationally difficult. What does that actually mean? Right? I actually looked at the architecture and found that it was indeed not very easy to deploy, as well as being inconvenient for application developers because it required cross-shard transactions to be considered differently from single sort of on-shard transactions. And then we had TiDB, which was being recommended by CacheDB, but never used at Square. So just a bit of background here. Within Block, Square and Cache are 2 different business units, but they also have 2 separate pieces of infrastructure for historical reasons. So things that are used by one do not necessarily work by the other. So actually, in terms of how we made our choice, the team was actually leaning towards manual sharding, but and so like, because this again was the blessed path, right? So even though TiDB satisfied many, but not all of the properties we had originally brainstormed, there were a lot of concerns about setup and operational cost. And we sort of went around and talked to a whole bunch of teams and looked at a whole bunch of other docs from other product teams. And what we found is that a lot of teams actually considered TiDB and then sort of shied away from it because they said, oh, we have to manage it ourselves, we got to set it up ourselves, we got to maintain it and update it ourselves. And like nobody on the Square side of the business had done this before. So, so there's definitely concerns about that. So what ended up happening is we're leaning towards manually sharding, And I was sort of having a bad night because I was thinking about how gross our code would get once we went with manual sharding. And then I decided to, since I was not sleeping anyways, I just to get up and look at the architecture of the test and look at the architecture of TiDB. And I guess based on distributed systems expertise from my PhD, I decided that TiDB was a reasonable option, both in terms of maintainability and scalability. Like, I acknowledged it would require work, but like it was doable. So then I decided to take a week and hack together a running cluster in production just to show people that yes, we can run TiDB. It was obviously no SSL, none of the sort of production readiness that you would expect, but we got it running. And then I convinced the team to change direction. So we dropped the manual sharding and switched over to TiDB. Questions or comments about this part of the journey? We still are managing the cluster. So like sorry? I mean, the cluster is currently running and only one person is actively still doing work on it. But we've only run for 2 weeks in production, so we don't know yet. But we're not actively doing stuff with it beyond sort of cleaning up the tech that we use for the migration itself. Yes?
So the manual sharding, does other teams, do they do manual sharding for other products?
That's correct. So other product teams, including, for example, invoices at Square, are doing manual sharding, and they basically maintain that logic inside their application.
And you mentioned you don't really like the manual sharding idea because the code will be very dirty. Well, has that been a problem? Is there a big enough pain point from the other teams?
That's a good question. So a lot of the teams that manually shard are actually much larger than ours. That's one data point. And in terms of how much like pain they go through, well, I've talked to a few teams. They took about roughly 6 months to manually shard the first time, and then like every 2 years they have to reshard. And when they do feature development, they always have to think about like how well manual sharding works or doesn't work. There's another interesting data point, which was while we were going around saying we're going to do manual sharding, I guess our GM, Willem, looked at our doc and said, please don't do manual sharding. Every single team at Square I've seen do manual sharding, they used to be high velocity teams, they became low velocity teams. So like, that was another point for us. Yeah.
One more question. So you said that CacheDB did a lot of probably legal and some reviews to get it like through, right? So why did they ended up not using it? Can you share that?
Yes. So I've already shared this with other folks in PingCAP. The main reason is disaster recovery. So like as an infrastructure team for CacheDB to support this, they require that you have cross-regional disaster recovery. As a relatively newer product within Square, we were okay with not having that, at least for the time being. But like that was a blocker for CacheDB. Other questions or comments?
Can you elaborate what you mean by disaster recovery? What is missing in TiDB to get
Sure.
that?
So at a high level bit, you want to be able to have an upper bound on both how much data you lose in the case of a regional failure, as well as an upper bound on how long it takes to recover. And based on the existing mechanism, namely TiCDC, they were not able to achieve the 10, I think it was a 10-minute time to recover that they wanted. Moreover, they did look at multi-cluster solutions, but they decided that those solutions were too complex and too expensive because they required running a lot more EKS clusters than they wanted to run. Does that address your question? Yeah, happy to chat after too. Other questions or comments before we move on? Thank you for all the questions, by the way. This makes the talk much more fun for me and for you. Okay, I'm going to move on. So the next part of the talk will be a little bit boring, but I hope informative. Areas of expected work. So first of all is the obvious one. This one, like if you're an application team, regardless of whether you have infrastructure support or not, you have to do this part. So application updates for compatibility. So one of the biggest pain points for us in terms of updates was that we were relying on the monotonic increasing auto-incrementing IDs throughout many parts of our application. And the fact that TiDB's sort of auto-incrementing IDs jump around a little bit because of the caching of IDs meant that we had to replace all the places we were sorting by IDs with sorting by timestamps. And you think this is not very hard, but we had a lot of places, and they interacted in very subtle ways. So we ended up denormalizing part of our database schema for this reason. So that was one bit of work. The other was removing dependencies on foreign keys. So what do I mean by dependencies on foreign keys? What I mean is we're using on-delete cascade for a variety of use cases, including GDPR and CCPA compliance. So we have to get rid of that dependence and then eventually re-implement that logic in Java. The last one, which Christina will get more into, is we had to remove the use of generated columns because we learned a little bit too late that generated columns are an experimental feature in TiDB. Questions about application updates for compatibility? We got one there and one there.
So regarding the sorting by the timestamp globally, how do you ensure the timestamp is, I mean, like there's the accuracy, right? It's different than the unique, the auto-incrementing ID. So how do you ensure that you can always sort by the timestamp?
We're relying on the timestamp oracle in the PD component of TiDB to have globally monotonically increasing timestamps. Yeah.
Did something go wrong with the generated columns, or did you not even try it?
I don't want to spoil Christina's part of the talk.
Okay.
But we'll get there soon. We'll get there soon. Other questions at this point? Okay, I'm going to go ahead. So the next phase of sort of validation, when you go to any new database, you have to validate that your system still achieves comparable performance compared to using MySQL. And this is, I want to be very clear here, we're not saying TiDB has to match MySQL performance. We're saying our service when running TiDB has to match our service when running MySQL. This is a subtle but important distinction because like if the database is not the bottleneck in your system, then you may not actually observe a huge performance degradation when you move to a slower database. So we did find some of these, as Christina will get into, and then we had to investigate and sort of fix the queries that were slower in TiDB. And TiDB is great, but like when you migrate from any system to any other system, I would be extremely surprised if you did not run into at least one of these things. So yeah. Questions about this? This was multiple weeks of benchmarking and performance experiments. Okay, moving on. So data migration was also like a bit of a pain point for us. We wanted to design a migration plan for orchestrating service deployments so that we didn't lose any data consistency and we also didn't lose any data. There were some limitations in the data migration tool. Thank you, Ed, for fixing the SSL issues, or at least asking people to fix the SSL issues. But there was also this issue of migrating from AWS RDS. You cannot take the global read lock because Amazon does not give you permissions to do so. Sorry, Amazon people, for calling that out. I'm sure there are good reasons for it. But because you cannot take the global read lock, you end up having to do a bit of shenanigans to get what we wanted. We ended up with a read-only replica on which we paused replication temporarily, and then we took a snapshot on that replica and then resumed it and waited for it to catch up. So there's a bit of an elaborate dance to get this migration working. Fortunately, we weren't trying to fully automate that whole process because we're just one product team, we're not an infra team. Questions about data migration?
One question, that process, the cutover time, how much downtime was that?
Very good question. We did this literally 2 weeks ago, and this was 8 minutes of downtime. We were waiting, we basically stopped all writes. It wasn't full downtime because we are in read-only mode. I have a backup slide about that if people are curious later. But like, yeah, we were in read-only mode for 8 minutes, and we queued all service messages, so we didn't lose any messages. Good question. Other questions?
So, do you have any data schema migration you need to do, like store procedures or any other stuff you need to migrate when you do this?
Yeah, so I alluded to this a little bit earlier, but yes, we also had to get rid of anything that required basically running constraint checking, anything that relied on constraint checking, like foreign key constraint checking, we had to migrate over to Java. So there were some migrations, but they weren't really large compared to the application changes. We also removed all of our foreign keys because we figured it would be more confusing for people to see the foreign keys and have them not do anything than to not see the foreign keys and then be confused about why. So that was a bit of a debate inside our team when we were first starting this journey.
I have a question. Here.
Oh, hello.
So, hi. So how long did it take you overall from when you started looking at TiDB to the time that you went live 2 weeks ago?
I think it was more than 6 months for, I guess, roughly 2.5 engineers, because I guess Christina and Jacqueline worked on other projects too while we were doing this, but Lei was on it full time. I was on it roughly half time, so roughly 2.5 engineers for about 6 months or so.
Okay, thank you.
Yeah. It has occurred to me that the space is small enough you could just shout. You don't actually need microphones.
That's probably true.
But
When you consider data migration in any project that you're doing, how do you weigh the scope of data migration versus the efficacy of the project? Like, when does data migration become a problem?
Define the scope of data migration. Like, are you talking about the effort it takes to do the migration?
Yes.
Okay. So if I'm understanding the question correctly, you're asking like, how do we decide whether or not this amount of work was worth it? Okay. In our case, like, if you look at the options we had, if we went with manually sharded MySQL, we'd probably have roughly an equal amount of work, and then in a few years we had to reshard again. If you look at sort of Aurora, that's again, at least from our point of view, a crutch for a short-term solution. And a lot of the other solutions had not yet been proven inside block. So it wasn't so much like, was this worth the work? It was more like, what choice do we have? Yeah, and it was choosing among different expensive options. Yeah, and I'll be very free to admit that we certainly underestimated the cost of this migration when we started. But let our sort of underestimation be your learning. Other questions or comments? Okay, let's continue. Let's continue. Do we skip a slide? Okay. The last bit of work, I know Matei at the beginning, like in the keynote, talked about how it was kind of, or sorry, not Matei, Max at the beginning talked about how it's unfortunate that we still have to shove data into Snowflake. But in our case, we do have to shove data into Snowflake, and there is a very good business reason for it. The business reason is that nobody else is on TiDB at Square, so we have to shove our data into Snowflake so we can join our data with everybody else's data to do the OLAP workloads. But this was a non-trivial amount of work because it turns out that most of this pipeline exists for MySQL at Square, but not for TiDB at Square. And the little differences are enough to cause us to have to re-implement many parts of it. If there's enough time, I may talk more about this later on. But this is just identifying a piece of work that if you need Snowflake or you need something like Snowflake for analytics, then you wind up with this particular bit of work.
One question on the diagram. So it looks like all the data is from the tables is being dumped into the S3, and from there you're taking it directly into ingesting it into the Snowpipe using Snowpipes.
I don't think we're actually using Snowpipe. I think we're just using normal staging loads. To be clear, I'm not an expert on Snowflake, so some of the terminology I might be wrong about.
Thank you.
Yeah. Other questions at this point? We got one over there. Yeah, at least I think that's a question. Maybe he just wants the mic.
Hey, so TiDB is OLTP plus OLAP. So have you considered using its OLAP power? Any reason to migrate to Snowflake? Any specific use cases you were looking for?
Yeah, so what I was saying earlier is that the reason we're migrating to Snowflake or migrating data to Snowflake is because all of the other data at Square lives in Snowflake, and we want to do joins against that. So for example, like names of customers, for example, transactions that a particular customer has had, or like appointments data, or receipts data, or invoices data. All of that lives in Snowflake at Square, and like we cannot convince like 10 other product teams to all migrate to TiDB very effectively, considering how much time we spent doing it. Yeah. Okay, I have lost my timekeeper. Sorry to call you out. But I'm going to continue. Hopefully I'm not running too far over time. Okay, so now I'm going to give the stage to Christina to start off on unexpected problems and solutions. You have to hold it pretty close.
Hello, I'm Christina. I work with Henry at Square/Block. So I'm going to start off as this section on this deep dive section where we talk a bit more about the unexpected things that we ran into in our TiDB adventures and our best efforts to solve them or at least address them. And specifically, I'll start off this section with a focus on performance and the query level issues that we ran into. So whenever you try to switch over to a new database, even though TiDB claims MySQL compatibility, there's always the fear of the unknown, especially with regards to performance. Will switching over to TiDB introduce new perf bottlenecks, perf issues? So no one likes surprises. So to avoid these surprises, before actually switching over in production, we ran best effort perf experiments in our staging environment. Specifically, that looked like running latency tests and load tests against our service level endpoints, not the actual queries, because that was our primary focus, like Henry mentioned earlier. So based on those results, we ran into some interesting findings. The first, I guess, high-level theme that came up was joins were noticeably slower in TiDB versus MySQL. Our perf test also helped us track down no-op joins that had no business existing in the first place in our code base, but removing them did reduce, I guess, roughly around, improve throughput by about 5% off the top of my head, but that was like low-hanging fruit. I think the key bottleneck for us that was most concerning, considering that we're write-heavy, is writes that involved table joins. So specifically, we saw that for one particular write like that in our critical path, that the throughput was 30% of the equivalent in RDS MySQL, which was not good. But this is like right off the box. So we proceeded to look closer at the execution plans about what exactly was happening. We noticed two things. One was that there were a lot of time was spent trying to fight for the lock across these multiple queries, which kind of makes sense given high concurrency. And the second issue, which is a bit more of a mystery that we still need to investigate further, is that the TiKV layer was quite busy for this for the queries that were happening in the throughput scenario. We were seeing updates happening for more keys than we expected that we did not see for the latency tests. We were still not quite sure where these extra keys are coming from, but the current hypothesis, very, very high-level hypothesis, is that this has something to do with the concurrency of writing to the same row at the same time. But we didn't want to block, like this investigation was taking a long time, we didn't want to block this we didn't want to block switchover in production any further, so we tabled this to post switchover in production, and for now we had our switchover 2 weeks ago, and then we were just resorting to a quick and dirty hack where we just simply break the query into two and avoid the join at all costs. But now that we've had our switchover 2 weeks ago, we do want to definitely revisit this now that we have the time, specifically by trying to come up with a more bare bones, minimum reproducible example, and get to the root cause of like what exactly is happening in this throughput scenario, and hopefully benefit the TiDB community. Yeah. And then, yeah, it seemed like a lot of people were interested in generated columns, so here we are finally. So I guess a bit more context about how we even got to generated columns. As Henry mentioned earlier, and for those who still have not maybe caught on, like in TiDB, auto-incremented IDs are not monotonically increasing. So we had to replace all sorting instances on that with sorting by timestamps. And that, one of the initial approaches we took with introducing those timestamps was to use generated columns. But that worked fine, except when we actually tried to index on the generated columns, we saw two sorts of unexpected behavior. First was that the results were just wrong. And then the second was also, in addition to that, the results were different depending on which columns were being selected in the query. But later on, we should have known this earlier, but later on we realized that generated columns in TiDB are an experimental feature anyway, and we don't want experimental features in production anyway, so we got rid of, the solution was to replace the generated columns with like explicitly manually added columns and doing backfills. Yes. So far I've talked about issues, performance and query related issues that we saw in staging, but now I'm going to talk a bit more about things that happened after the actual switchover in production, which is interesting. So we had our switchover 2 weeks ago, and then about a couple hours after the switchover, we noticed one particular endpoint, thankfully not a critical functionality in our product, timing out more frequently than usual. And so I got a Slack message from Henry at 9 p.m. being like, "Hey, Christina, this query is timing out more than usual. Can you look at it?" So at 9 p.m., I was looking at the execution plans of this particular query, and turns out that the TiKV level was very busy with RPCs for fetching information about columns that were in the where clause that could easily be optimized using an index. And also this, I guess more context on this query. This is a query involving joins across 3 tables. It has never been it was always one of our more problematic queries, but I think we are seeing the latency impact being more exaggerated and noticeable in TiDB versus our regular RDS. So that was happening. So based on what we found in the execution plans, we decided to try to add a composite index that makes sure we cover all the columns in the where clause. That took a while, but eventually that did help reduce timeouts. And I think, thankfully, that was the only big performance issue we saw post-switchover in production 2 weeks ago. So overall, not bad, in my opinion. But I think the key takeaway from this overall, not just this particular instance, but the overall journey and adventures in TiDB is that, TiDB, there is the claim that it is MySQL compliant, but that doesn't quite, you can't take that at face value, especially with performance, which was expected. But I think it was definitely crucial to, pay due diligence, take time to investigate and de-risk performance implications when actually switching over to TiDB. But yeah, and then I'll hand it over to Henry for the remaining talk.
One quick question. Did any queries run faster than expected when you migrated over?
There were, but we were very happy, but we just we didn't quite take the time to investigate why exactly. But some of the queries were surprisingly faster, but we were like, yay, but let's just move on and focus on the bottlenecks. But yeah, we didn't focus on the bottlenecks, but there were perf wins for sure, yeah.
So they say the
There's a
squeaky
question.
wheel gets the attention. One more question? Yeah, we are.
Sorry,
I'm being
question.
reminded that we're running a little bit out of time, but you should go ahead with your question.
Sorry, question for her. When she said missing indexes, what do you mean? Were they missing by design, or were they missing
in the
by
sense-
mistake, or?
Yeah, so this was an oversight on our part. So I think the speculation is that for certain classes of queries, MySQL either does table scans faster or uses partial indexes more effectively. So in this case, we had to add an explicit index that matched exactly with the join query, and that sort of fixed it. But we hadn't realized this because we didn't see this problem in staging. So they were missing, like, not intentionally, but inadvertently. Christina, do you want to add something?
Yeah, I think one of the key reasons we didn't see this in we didn't catch this in staging was because, like, fundamentally we do have different data in staging and production, and I think the patterns in production were more likely to make this issue visible, especially since it's like a 3-table join. The particular pattern of, you know, like having that particular pattern and relationship of the data in staging was, yeah, it's hard to predict. Yeah. Anyways.
Okay, since we're running low on time, I will go very quickly over the last 2 slides before we go on to more open session. So, quick learning about EKS Cuddle. It turns out that when you try to set up an EKS cluster using EKS Cuddle in an environment with no outbound internet connection, it doesn't like you very much. So we could have gone with Terraform or any of the sort of other more heavyweight infrastructure as code techniques, but we decided to just hack this with Ed because we're a product team and we didn't want to spend that much time playing with EKS. So we ended up literally just writing bash scripts that edited the environment while EKS Cuddle was running. That was kind of just mostly for fun. We can talk more about it offline if we have time. The last bit was kind of interesting for those of you who want to get stuff into Snowflake. Turns out that the S3 connector, which is a Confluent Cloud product, is not capable of using a connect proxy with credentials. So like, we actually contacted their customer support, and they said, no, we don't support this. So I said, fine, I'll shove your traffic through a SOCAT and force it with credentials through our cloud proxy, which is just a squid proxy. So with that, I will conclude. So we chose TiDB due to previous use at Block and a more ergonomic alternative to sharded MySQL. Without infra support, we were able to deploy TiDB, but this is with a non-trivial amount of work and required hacking infra. So like if your product team does not have infra background, it may not be advisable. Last thing is that we noticed, as Christina mentioned, TiDB is largely compatible with MySQL, but we would not recommend deploying without sufficient preparation and benchmarks. And with that, I'll take additional questions, but I am also running out of time.
Hey, Henry. A couple of questions. You mentioned you ran benchmarks for correctness and I'm assuming scale as well. Can you tell a little bit more detail about what those benchmarks are, what metrics you were testing for correctness, what did you test? Another thing you mentioned, you used TiCDC to move data to Snowflake. Can you share your experience with TiCDC, how that went along?
Can I go over a little bit? Okay. So the first question was around, sorry, remind me again.
Benchmarks.
Benchmarks, yes. So what benchmarks did we run? What correctness things did we check? So the way my team does deployments, like any deployment of new code, is we run through a whole set of benchmarks against every single gRPC endpoint that's hit by our front end. So we measure latency, we measure throughput, we measure failure rates. Typically, we have 0 failure rates during the perf tests, but like if we see performance degradations, we'll usually pause the deployment and say, like, stop, we need to investigate what's going on, if it's like a large performance degradation. So these are the types of tests that we ran for TiDB as well. So we pointed our performance testing pod instance at TiDB, and then we just ran the exact same benchmarks that we normally run before any deployment. So that's for the first one. For correctness, it's similar. We have a set of smoke tests. We run a combination of manual and automated tests for our AI and also for the general sending and receiving of messages. So we ran those as well. And we ran them obviously repeatedly until we figured out what was going on. Your second question, how are we using TiCDC? We're using TiCDC in sort of the original, I would argue the way it was probably designed to be used, which is shoving stuff into Kafka. So we just point TiCDC at Kafka, and then another team owns a component, that S3 sync component I was talking about. That is what we use for shoving data into S3, and then had a separate script for pulling data from S3 into Snowflake.
Got it. I guess my question was, did you run into any issues with respect to that? Like, what was your scale like for CDC?
Yes, whenever we did a backfill, CDC would fall behind by somewhere between 6 and 8 hours. And a backfill is basically a single-threaded batch insert, which I believe Morgan on the cache team also ran. So yes, like this is why I've always argued that TiCDC is not good for DR because of this precise problem. But I think for our purposes, if we're like 8 hours behind on analytics, as many people have said, it's not great, but like it's not yet a showstopper for us. Yeah.
Got it. Thanks.
Any last questions? If not, you can always find us here at the conference, and those are our emails for now. Who knows what emails will change as we rename to Block. All right.
Thank you very much.
Thank you, everybody.